pizza, once a proud symbol of Italian cuisine, was raised by America into a global icon, powering an industry worth tens of billions of dollars. Each year, the world consumes over 5 billion pizzas, and the US alone accounts for 2/3 of that number. But have you ever wondered how such a staggering amount of pizza is made? The secret lies in a highly modernized journey, from golden wheat fields to sensory testing labs that measure quality down to the millimeter. Every step, from dough mixing, tray dividing, proofing, baking, labeling to delivery, is programmed with the precision of an industrial symphony, all to produce those aromatic pizza slices or airy, fluffy croissants. Today, Agriculture Insight invites you into a world where technology meets American culinary mastery, where the humble pizza becomes a symbol of mass production and craftsmanship, the American way. Pizza, a small circle, yet a powerful symbol of the entire fast food industry. It's often called an addiction flavored with oregano and tomato sauce, capturing the hearts and stomachs of billions across the globe every single day. You can find a $5 pizza baked in a brick oven on a Naples street corner, or order a $12,000 version at a luxury restaurant in New York, topped with caviar, truffles, and gold leaf. And while a pizza can be sliced into 8 even pieces, the battle for each slice of the market is far from evenly split. For decades, Pizza Hut reigned supreme with its classic dine-in restaurants, family-friendly ambiance, and broad menu. But since 2018, Domino's flipped the script, becoming the largest pizza chain in the US by revenue, thanks to its massive automation systems and highly optimized logistics network. The race is so fierce that even McDonald's, the global fast food titan, once tried to enter the pizza market back in the 1980s. But eventually, even McDonald's had to retreat quietly, unable to keep up with Domino's. So yes, pizza is more than just food. It's a global culinary icon where creativity, technology, and business collide on a single crispy crust. Which pizza is your true love? Drop a comment below and share it with me. And right now, join me on a breathtaking journey through endless wheat fields, the very beginning of those golden, crispy crusts that make the world fall in love with pizza. In June, across the states of Kansas, the wheat capitals of the United States, endless fields turn a brilliant shade of gold under the summer sun. It's a familiar signal. Harvest season has begun. Right then, the massive combine harvesters begin to roll. Each one stands nearly 3 meters tall, stretches over 10 meters long, so massive that anyone standing beside it looks completely dwarfed by the steel giant. Small in size, perhaps, but still in full command of the entire harvest. At the front, a sharp cutting blade glides just above the ground, neatly drawing whole stalks into the machine. The leftover straw is returned to the field like a natural mulch, while the clean kernels are collected into an onboard storage tank. Each modern harvester can collect over 90 tons of wheat per hour, an astonishing figure, equal to the labor of hundreds of workers operating non-stop, leaving behind the bulky, complicated machines of the past that once dominated the fields. These days, farmers no longer have to bend over with sickles to harvest each stalk by hand. But that doesn't mean they have it easy. The fields today are more expansive than ever, stretching endlessly to the horizon, so vast that even a bird in flight might never reach the end. To make it more challenging, harvesting can only happen in the early morning or late afternoon, when moisture levels are just right to avoid cracked or damaged grains. That's why lunch often means a cold meal eaten in a hurry under the shade of a harvester, chewing between rows, eyes still watching the field bathed in golden light. Out here, every minute counts, and true rest becomes a rare luxury during harvest season. Then it's right back to the harvest. grain tank is full, the wheat is unloaded directly into large trucks driving alongside the field, or a specialized truck drives alongside the harvester, receiving a steady stream of wheat pouring from the unloading pipe, all happening seamlessly, without the machine stopping for even a second. This synchronized and precise process helps optimize time, maintain ideal freshness and dryness, and preserve the grain's quality, minimizing post-harvest losses to the greatest extent. After being harvested from vast wheat fields, the grain is transported to a grain storage facility. Here, the wheat is unloaded into underground receiving pits. These are steel-reinforced pits, built directly beneath the receiving area of the facility. From these pits, the wheat is moved by conveyor belts or bucket elevators into large silos, towering cylindrical storage tanks made of steel or concrete. Inside the silos, the wheat is stored under strictly controlled conditions for humidity, temperature, and ventilation. Inside these seemingly empty metal ducts, tons of wheat grains are silently moving, weaving through every bend and corner, making their way to specific areas such as cleaning machines and moisture conditioning units within the factory. After being thoroughly cleaned and resting inside massive silos, wheat begins its next journey, heading to the flour mill. But instead of walking or hopping on a train, the wheat slides through enclosed pipes and industrial chutes. At the end of the slide, tons of golden wheat grains come rushing down into enormous trucks, each capable of carrying 25 to 30 tons, roughly the weight of 5 full-grown elephants. But don't think they can just hit the road right away. Before leaving the site, each truck must pass through an electronic weigh station, ensuring the load is within legal limits and recording the exact weight down to the last kilogram. This strict monitoring isn't just about avoiding overloaded trucks. It's also essential for inventory management and traceability. In the food processing industry, every grain of wheat must have its own identity papers. Inside the flour mill, after undergoing initial cleaning, the wheat grains are passed through an additional round of screening, this time much more meticulous. From the screening section, the grains are sent to a central distribution hopper system, where automated valves precisely control the flow of wheat into the next stages of processing. However, before they can be milled, the grains must go through large tempering tanks. The wheat is lightly moistened and left to rest for 12 to 24 hours. This softens the outer bran layer, making it easier to separate during milling. Next comes what's often referred to as the heart of the factory, a long line of modern roller mills. In modern factories, a single production line can include 20 to 40 machines like this, each responsible for a different stage of grinding, from coarse to intermediate to fine milling. This setup maximizes both efficiency and flour quality, especially for specialty flours like pizza flour. Each pair of steel rollers spins steadily, crushing the wheat kernels and gently separating the bran, the germ, and the bright white endosperm inside. It's this endosperm, rich in starch and protein, that becomes the smooth white flour, the very foundation of a perfect pizza crust. After milling, the flour isn't ready for packaging just yet. You think those machines bouncing up and down like they've had one too many espressos? They're not dancing for fun. They're plan sifters, the unsung heroes making sure your pizza flour is smoother than your best pickup line. A large rectangular machine suspended by flexible rods, containing multiple layers of fine mesh screens. The machine gently vibrates, allowing the flour to be sorted by size with micron-level precision. Flour that meets the standard moves forward, while coarser particles are sent back for regrinding. This is the final and most critical sifting stage, ensuring pizza flour comes out consistently fine and high quality. Because with pizza, even the tiniest inconsistency can throw off the perfect crust. Next, the fine flour is transported through a high-pressure pneumatic system. Think of it as a high-speed expressway just for flour. It's carried to a cyclone separator, where centrifugal force separates the flour from the airstream, allowing for clean, dust-free, and lossless recovery. And those tangled stainless steel pipes that look like a maze? They're part of the system that delivers flour to the blending station. Here, the fine flour is given its final adjustments. Depending on the end product, enzymes, malt flour, or B vitamins may be added. Finally, after passing the last quality check for fineness and fluffiness, the flour is sent to the automated packing area. Here, every stream of fine flour is precisely weighed, filled into pre-labeled bags, and tightly sealed to preserve its freshness. Each bag typically weighs around 25 kilograms, just the right size for bakeries and food factories. Robotic arms carefully lift each bag of flour one by one, smoothly rotating and placing them neatly onto waiting pallets. The finished flour bags are then neatly stacked in climate-controlled storage, where both temperature and humidity are carefully monitored. And just like that, every pizza crust begins with a journey this meticulous. Right now, let's step into the pizza production factory, where all the anticipation truly begins. But before those golden, crispy pizza crusts hit the oven, let's take a quick detour to meet its flour-based cousin, the croissant, a pastry that also begins with the same soft white flour. The process begins with the most essential base ingredient, flour. First, a large amount of fine white flour is poured into the industrial mixing bowl, the very backbone of every croissant dough. Next comes the yeast, usually in fresh or compressed form. It's what brings the dough to life, giving the croissant its airy rise and soft texture. Then comes the cold water. Here's a little secret. To keep the dough cool and stable, especially during high-speed mixing, ice water or chilled water is often used. This helps prevent the butter from melting too soon later in the process and ensures the dough stays firm and ready for lamination. All of it goes into a massive industrial mixer, where powerful mixing arms knead the dough into a smooth, elastic mass, ready for the next act, the art of lamination. After the mixing and resting process is complete, the croissant dough moves on to a particularly crucial stage, lamination and shaping. Here the dough passes through an automated rolling system, where it's flattened and stretched into long, even sheets, as smooth and pale as ivory silk. Each sheet isn't just plain dough, it's a precise fusion of dough and butter, folded, rolled, and rested repeatedly in a process known as lamination. After every fold, the machine gently sprinkles a thin layer of flour over the surface, not only to prevent sticking, but also to ensure each layer stacks cleanly and distinctly. The alignment laser acts like the eyes of the production line, precisely positioning the dough along the programmed axis. This allows the rolling machine to shape each piece smoothly and uniformly. It's especially critical for croissants because even a slight misalignment can ruin the signature layered structure of the pastry. After being rolled into thin, the croissant dough is sent into a cutting machine that slices it into triangular shapes. However, along the outer edges of the dough sheet, excess strips often appear uneven, jagged, or fall outside the required dimensions. At this point, the automatic edge trimming system takes over. Additional side blades remove the unwanted edges, leaving each dough piece clean-cut, symmetrical, and easy to roll. After the croissant dough is cut, it moves on to the spreading stage, where each piece is gently separated and evenly arranged on the conveyor belt. Depending on the type of croissant being produced, some are rolled immediately, while others are upgraded with rich almond filling, fragrant chocolate, or savory ham and cheese. Then, intelligent rollers gently roll each piece from base to tip, creating the signature crescent shape we all recognize. The finished croissants look perfectly uniform, glossy, and irresistibly appealing, ready to head into the oven. The trays of dough now enter massive industrial ovens, where hundreds of croissants begin their spectacular transformation. At a temperature of around 107 to 190 degrees Celsius, the buttery layers slowly rise and expand. Each layer turns crisp and the edges curl upward with proud elegance. In just 15 to 20 minutes, you'll witness something close to magical. From simple rolled dough, the croissants emerge golden brown, light and airy. Then the croissants are transferred to the automated packaging area. Here they are sorted and neatly placed into bags. Each package is vacuum sealed and ready to be shipped to bakeries, supermarkets, and cafes around the world. And now comes the moment we've all been waiting for. Don't forget, we're still on a journey to create the perfect pizza. It all begins with the crispy, chewy crust, the foundation that can make or break a great pizza. Once the dough has rested long enough, it's divided into long strips and passed through rollers. Next, the dough enters the shaping and cutting stage, where circular, square, or oval cutters form each base precisely. Have you ever noticed those tiny little holes on a pizza crust? They look like someone gently poked the dough with a fork. Those holes actually help steam escape during baking, preventing the crust from puffing up or cracking. And this is where the real differences begin to show. If the croissant is a symphony of butter and layers, pizza is a playground of tomato sauce, cheese, and whatever flavors your heart desires. At this stage, the pizza crust is partially baked to set its structure, lightly dry the surface, and prevent the tomato sauce from soaking into the dough later on. Next, the tomato sauce is gently spread across the crust. This special sauce is made from ripe, juicy tomatoes blended with garlic, oregano, basil, and a touch of olive oil, creating a rich, slightly sweet, and aromatic flavor that defines a classic pizza. The automatic cheese applicator operates with absolute precision. It uses fresh mozzarella, a cheese famous for its smooth melt, glossy finish, and rich texture that stays soft without releasing excess moisture. This is the secret weapon behind the irresistible appeal of every pizza. The amount of cheese is pre-measured according to specific recipes, depending on the pizza type, from classic to premium, to ensure the perfect stretch and deliciously melty richness when baked. Next, toppings like pepperoni, sausage, or bacon are automatically distributed over the freshly layered cheese. Slices of bright red pepperoni are neatly arranged, creating a visually appealing pattern and ensuring every bite is packed with rich, savory flavor. Before packaging, each pizza takes a quick trip through a gentle heating tunnel, like a mini spa session where the cheese melts just enough to hug the toppings tightly. This helps lock everything in place so nothing slides around during transport. Even better, the heat gives the surface a light sterilization, keeping the pizza fresh and safe for longer. After exiting the heating tunnel, the pizzas are moved to the packaging area. First, each pizza is tightly wrapped in plastic film to preserve freshness and maintain its shape during transport. Then, it's placed into a tray or box, labeled with product information and expiry date, and sent to cold storage for preservation before distribution. After that, the pizzas are transported to supermarkets, convenience stores, and distribution centers across the country. They are kept in consistently cold conditions throughout the journey to preserve their quality. And just like that, each fresh and delicious pizza is ready to become part of the daily meals of millions of families. If you enjoyed this video, don't forget to like, share, and leave a comment. Hello everyone. Did you know that potatoes are one of the most popular foods in the world? Every year, over 300 million tons of potatoes are consumed globally, with China and the United States leading in production. American farmers produce 44.1 million tons of potatoes each year. In 2023, this contributes about $101 billion to American economy. An average American can eat about 4.5 metric tons of potatoes over their lifetime. So have you ever wondered how farmers manage to harvest such an enormous quantity to meet our demands? From soil preparation and planting to harvesting and storage, the journey of potatoes from farm to table is far more complex than you might think. Thanks to modern technology, American farmers can manage dozens of acres of potatoes, carefully monitoring every stage from irrigation to harvest with precision and efficiency. In today's video, we'll explore this entire process, from planting to the intricate steps of processing potatoes in the factory. Seed potatoes are specially selected for their quality and disease resistance. They are typically cut into chunks with at least 1 or 2 eyes per chunk, as the eyes are where the new plants sprout. Efficient soil preparation is crucial for successful potato growth. This involves plowing and tilling the soil to a suitable depth, usually between 8 to 12 inches, to promote good root development and drainage. Fertilizer is also an indispensable part for the growth of potatoes. With modern machinery, thousands of potatoes have been covered on hectares of fields. Large farm owners will often invest in automatic irrigation systems. After 20 days, the potato sprouts have grown into green plants. As the plants grow, it is important to monitor for pests and diseases such as potato beetles or leaf blight. When the potato plant flowers, it is a sign that the primary tuber has formed. This stage coincides with the onset of tuber formation, a process in which the plant begins to divert more resources from leaf growth to underground tuber expansion. Potatoes are typically ready for harvest after the plants have flowered and the leaves begin to yellow and die back, usually about 2 to 3 weeks after flowering. It's also crucial to test the firmness of the potato skins to ensure they are sufficiently set and do not get damaged easily when handled. A mechanical harvester can gently lift the potatoes from the ground while separating them from the soil and debris. A windrower may be used beforehand to clear and air dry the potatoes on the ground if weather permits. Because the farm is very large, people need to check the machines carefully to make sure they are working at full capacity. The harvester's speed should be adjusted to suit field conditions and soil moisture to avoid damaging the potatoes. Farmers need to closely monitor the harvesting process to promptly adjust machinery and methods to minimize loss and damage to potatoes. Tons of potatoes are hiding underground. The golden potatoes in the ground are now moving the line. Farmers stand on the back of the cart and sort out the bad potatoes. With modern machinery, it only takes 7 hours to harvest a 5-hectare farm. Potatoes are cured in a controlled environment to develop a firm skin and heal any minor injuries. Such a potato harvester would cost anywhere from $100,000 to $150,000. Trucks loaded with potatoes are ready to take the potatoes to the factory. After the harvest, trucks filled with potatoes begin moving to a warehouse about 1 kilometer away. During transportation, farmers need to go slowly so that the potatoes do not get crushed. Potato storage should be maintained at a temperature of 4 degrees Celsius to 10 degrees Celsius to prevent germination and limit the growth of bacteria and mold. Potatoes should be stored in a dry, well-ventilated place and protected from light to prevent greening and the formation of solanine. Potatoes are transported by automatic conveyor belts to replace human labor. There will be a few workers standing next to the conveyor belt to remove any diseased potatoes. Just like that, tons of potatoes were easily put into storage. If there is no storage, immediately after harvest, farmers will process the potatoes to bring them to the factory. Sand will be screened through soil filter. Potatoes continue their journey to the factory. Potatoes are packaged at the factory to be brought to supermarkets for consumers. First, they are fed into a conveyor belt to be taken to the washing tank. The washing liquid contains chemicals that help remove dirt and make the potatoes smoother and whiter. Then, the potato packages will be packed in fixed weight. Finally, the bags of watered potatoes are transported to supermarkets for sale to consumers. Factories often receive potatoes in bulk from farms. They are usually stored in large bags. The potatoes are then fed onto conveyor belts to begin the production process. The potatoes are first cleaned to remove soil, stones, and other debris. This is typically done using a water bath or mechanical scrubbers. After cleaning, potatoes are sorted by size, weight, and quality to ensure consistency in the final product. Next, the potato skin is peeled. Mechanical peelers usually scrape the skin with an abrasive surface. After peeling, potatoes are inspected manually to remove defective parts. They are put into chemical baths to give them a more attractive color. They are then fed into modern cutting machines to be cut into shapes like slices to make potato chips. They are rinsed with clean water again to ensure no chemicals remain. Looking at these potato slices, do you find them appealing? Cut potatoes are often blanched by immersing them in hot water or steam. Blanching helps to remove excess sugars, reduce microbial load, and preserve color. Post-blanching, potatoes are dried to remove moisture on the surface. This step is crucial for achieving the desired texture in fried products and also helps in extending the shelf life. The dryer uses hot air to circulate around the surface of the potatoes to cook and crisp them. Potatoes will be dried within 15 to 20 minutes. Frying with heat does not require the use of cooking oil, helping to reduce the amount of fat and calories in French fries. Potatoes are crispy on the outside, but may be less crispy than fried in oil. However, this method still retains the moisture and flavor of the potatoes. French fry products are cooled at room temperature or with forced air. Engineers control the entire process through a monitoring system. This process is fully automated by machines. Crispy potato slices are out of the oven. They are divided into specific portions for packaging. The final products are then packaged in a controlled environment. Packaging is designed to protect the product from air, moisture, and other external factors that could degrade its quality. Packaged products are stored in warehouses at controlled temperatures until they are distributed to retailers or directly to consumers. In addition, the factory has a laboratory available so that professors can measure the safety and nutrition of products before selling them on the market. The whole video just explained how American farmers harvest millions of acres of potatoes. Thanks for sticking with me through the whole video. I hope you picked up some new insights. Do you have any questions after watching? Feel free to drop a comment so I can help you out. And don't forget to like and subscribe to support me in creating more useful videos for you. Goodbye, see you in next video. Hello everyone and welcome back to Agriculture Insight. Is your busy life stressing you out? If so, come with us and immerse yourself in the endless wheat fields stretching across America, where golden wheat is ripe and ready for harvest. In 2023, American farmers harvested an incredible 49.3 million tons of wheat, contributing significantly to the global economy and food security. That's an impressive number. But do you know the secret behind achieving such a massive yield? It's all thanks to advanced agricultural technology and modern harvesting systems that American farmers have adopted. Today, we're taking a trip to Kansas, North Dakota, and Montana, America's top wheat-producing states. Join the farmers as we follow the process from planting to harvest. Explore the cutting-edge technologies that make their work more efficient and get an up-close look at how wheat is harvested and processed into products you've probably never seen before. Ready to go? Let's get this journey started. Growing and harvesting wheat requires a combination of modern agricultural methods, from selecting seeds and caring for the crops, to harvesting with advanced technology. Many farms in the U.S. produce wheat for various purposes, such as flour production, cereals, and bread products. The price of wheat is around $250 per ton. Wheat harvesting season in the U.S. mainly occurs in the summer, from June to August, depending on the region and climate conditions. This is when the wheat has reached maturity, with an ideal moisture level for harvesting and processing. Farmers carefully choose the exact time based on the crop's development and the type of wheat being grown. On large farms, modern machinery like combine harvesters is used to harvest the wheat. These machines not only cut the wheat but also thresh the grain from the stalk, making the harvesting process faster and more efficient. Fast forward to September or October, and a new wheat growing season kicks off as the weather cools down after the scorching summer days. Most farms in the U.S. plant winter wheat. Different wheat varieties have different growth cycles, typically taking 120 to 150 days to reach full maturity. Kansas, with its mild winters, warm summers, flat plains, and moderate rainfall, offers the perfect natural conditions, making it the largest wheat-producing state in the country. The wheat growing process begins with selecting the right seeds. Farmers usually purchase wheat seeds from reputable seed companies. Before doing so, they check all the conditions of the seeds, including germination rate, origin, nutrient analysis, and field testing. The wheat seeds are treated with chemicals to protect the crops from threats like pests, mold, and other adverse factors during the germination and early growth stages. After each season, the soil used for growing wheat becomes compacted and overgrown with weeds, reducing its looseness. Before planting wheat, farmers must till the soil to loosen it up and create ideal conditions for wheat roots to grow deep into the ground. Tractors with plows are used in the fields, following predetermined rows, with plowing depths typically ranging from 20 to 30 centimeters to ensure the topsoil is thoroughly loosened. Once the soil has been tilled, the prepared seeds are loaded into the compartments of a seed drill to continue their journey across the field. As the machine moves across the field, the wheat seeds are automatically dropped into the soil through holes in the seed drill. Modern seed drills can plant evenly, quickly, and accurately over large areas. After sowing, wheat requires careful attention, particularly in providing adequate water and nutrients. Many wheat farms are equipped with automated irrigation systems. One of the most common systems used in wheat fields is the sprinkler irrigation system. This system consists of water nozzles installed along pipelines, which create water sprays or small showers that mimic natural rainfall. Additionally, there are high-pressure sprinkler systems that feature a central water pipe capable of rotating 360 degrees, allowing for uniform water distribution over the field. Farmers often use synthetic fertilizers that contain nitrogen, phosphorus, and potassium to provide the necessary nutrients for the crops. About 2 months into the growth process, wheat heads start to appear at the top of the stems. Each wheat head contains both male and female flowers on the same plant, allowing wheat to self-pollinate without the need for wind or insects. When the wheat plants turn a straw yellow or brown color, it's a sign that the crop is mature and ready for harvest. The plants will be fully dry, and the wheat heads will have a uniform golden color. The entire harvesting process is handled by machinery. The use of modern equipment allows American farmers to harvest tens of tons of wheat in just a few hours. The combine harvester plays a key role in this process, with each machine costing hundreds of thousands of dollars. It integrates 3 main functions: cutting, threshing, and separating the grain in one seamless step. The combine harvester can cover large areas quickly, saving both time and labor. The wheat grains are carefully harvested with minimal breakage or damage compared to manual methods. As the machine moves through the field, the cutter bar at the front slices the wheat plants close to the ground. Once cut, the wheat plants are carried into the machine via a conveyor belt, preparing them for the threshing and separating process. A rotating shaft system will separate the grain from the wheat stalk. They will then go through a screening machine to remove impurities and leave only the wheat grains. The grain is then transported onto the machine, ready for transport to the truck, and the excess straw is discharged directly outside. Once the grain tank on the harvester is full, the wheat grains are transferred to trucks or trailers to be transported to storage facilities. Wheat is typically stored in tall, cylindrical silos made of steel or concrete, capable of storing large quantities of grain. The silos protect the wheat from environmental factors such as rain, sunlight, and pests. Inside the silo, there is an elevator system that makes it easy to transport large quantities of wheat grain. After the combine harvester cuts and separates the grain, the leftover straw remains on the field. A baler is used to gather this straw and compress it into bales for easy transport and storage. Depending on the type of baler, the straw can be compressed into either rectangular or round bales. Straw bales can be used for various purposes, such as livestock feed or composting for organic fertilizer. After being harvested, wheat grains can be used as seeds or sent to factories for processing into flour. From flour, familiar foods like bread, croissants, and instant noodles can be made. Now let's take a tour of a flour mill, a bread factory, croissant factory, and an instant noodle factory. First, let's visit the flour processing factory. Here, the wheat is passed through a cleaning system to remove dust, stones, husks, and other impurities. This process ensures the quality of the grain before milling. The cleaned wheat is then sent to the milling machines. In these machines, the wheat kernels are gradually ground down by rollers or hammer mills, producing coarse flour. During this process, the bran is separated from the inner part of the grain. After milling, the flour is sifted through filters to classify it by fineness. The fine flour is separated and prepared for packaging. Once the flour meets the desired quality, it is packed into bags or shipment to the market or stored in the factory's warehouse before distribution. Next, let's visit the bread factory. The main ingredients include wheat flour, yeast, water, salt, sugar, and fat. These ingredients are placed in large mixers to form a dough. This process activates the yeast and creates the gluten structure in the dough. After mixing, the dough is left to rise for about 1 to 2 hours, allowing it to expand and develop its soft, airy texture. Once risen, the dough is lightly kneaded again to release air and then divided into smaller portions according to the standard weight for each type of bread. A dough divider ensures the portions are uniform in size. The divided dough is then shaped into loaves on an assembly line, ready to be baked in ovens at approximately 250 degrees C, 480 degrees Celsius, for around 30 minutes. Once baked, the bread is golden brown with a crispy crust and a soft interior. After baking, the bread is cooled on conveyor belts. Once fully cooled, it is packaged in bags to keep it fresh for longer. Next, let's head to the croissant factory. The process here is almost identical to that of bread, with one key difference. The dough is rolled out evenly into thin sheets before being cut into smaller pieces and shaped into croissants. After baking, the golden croissants are packaged on the production line and made ready for the market. Finally, we visit the instant noodle factory. The main ingredients include wheat flour, cooking oil, salt, spices, and safe additives. Before processing, the wheat flour undergoes strict quality control in the lab to ensure its standards. The flour, along with other ingredients like water and salt, is placed in large mixers. The dough mixing and kneading process is fully automated, ensuring the dough reaches the required smooth and elastic consistency to form noodles. Once kneaded, the dough is rolled into thin sheets by rolling machines. These sheets are then cut into thin, uniform noodle strands by an automatic cutting machine. The thickness and size of the noodles are closely controlled to ensure consistency. After cutting, the noodles are sent into a steamer. This process is fully enclosed, using steam and standard pressure. Once steamed, the noodles are cut to shorter lengths and placed into frying molds. The oil temperature is kept stable, with fresh oil continually added to replace the evaporated oil. After frying, the noodles are cooled before moving to the packaging section. The packaging line wraps the noodles with seasoning packets, ready for distribution. The noodle packages are then transported via conveyor belts for boxing and prepared for the market. Now you have a complete overview of how American farmers harvest millions of tons of wheat each year. From preparing the soil and caring for the crops to using modern machinery to harvest and transport the wheat to processing factories. It's a long process filled with dedication, precision, and hard work. So the next time you enjoy a slice of soft bread or a delicious pastry, remember all the effort that went into bringing those wheat grains to you. Thank you for joining me throughout this video. If you have any questions or comments, feel free to leave them down below. Don't forget to like the video and subscribe to the channel for more fascinating insights into the world of agriculture. Goodbye, and see you in the next video. Investing in machinery might seem like a big expense for small factories, but it's often well worth it. Modern machines improve efficiency, reduce waste, and enhance hygiene. Not to mention, they save labor costs. As demand for chicken products grows globally, these smaller plants can now keep up, tapping into a market that was once out of reach. Past, chicken processing was a grueling, labor-intensive industry with numerous challenges. Today, thanks to modern technology and automated machinery, the landscape has changed dramatically. Automation has improved every aspect of the process, from speed and hygiene to safety and environmental sustainability. By investing in high-tech equipment, chicken factories are able to produce affordable, high-quality products that meet the demands of consumers around the world. As technology continues to evolve, the future looks even brighter for poultry processing. Advanced AI, robotics, and data analysis will likely bring further improvements, creating an industry that is faster, safer, and more efficient than ever. So next time you pick up a pack of chicken from the store, you can thank modern machinery for making it all possible, without a single feather in sight. So that's the story about chicken meat processing. Hope you'll enjoy it, Don't forget to like and subscribe to our YouTube channel to get notified when our exciting videos go live. Goodbye.